Data from Energy Market Authority and Singapore Power Services shows that about 33% of household electricity is used for cooling the interior of the building using aircons, while 10% is used to heat bathing water, totaling up to almost half of the total domestic energy consumption. Thus, our group decided to design a device which can achieve cooling the interior and heating water at the same time.
Let's look at some examples of conventional shading. In these cases, sunlight is partially absorbed by the shading material but not reflected. As a result, the temperature of the material will increase. The material will re-emit the excess energy in the form of infrared radiation to the region below it, which is at a lower temperature. Hence, it will still be warm below the shade. Similarly, for curtains and walls, the solar energy absorbed is re-emitted as infrared radiation into the rooms, resulting in significant warming up of the interior of the building.
To illustrate our point, recall your experience entering a car which has been parked in the open for a period of time. Doesn't it feel like entering an oven? In the cases of industry and central aircon systems, water is used for cooling. This is due to the large specific heat capacity of water, which is 4200 joules per kg per Kelvin.
Taking this into consideration, we design a water-cooled shading panel. Our device consists of two layers of plastic laminated together. The upper layer, which will be facing the sun, is made of 0.5 mm Teflon, while the lower layer is made of 0.5 mm PVC. The lower layer is made into continuous thin grooves, which acts as a channel for water to flow.
Our homemade panel comes with a thermal-insulated 50-litre water storage tank, which is connected to the panel via an inlet and an outlet. Cool water from the storage tank enters the lower part of the panel through the inlet and fills the entire panel. Water in the panel, which has been heated by the solar radiation, flows back into the storage tank through the outlet at the upper side. This process is assisted by a fish tank water pump and regulated by a thermocouple digital temperature controller. The principle underlying our design is simple. Solar radiation incident on the panel is absorbed by the Teflon. The heat is then conducted to the water within the channels. Water molecules absorb the thermal energy and move at higher root mean square velocities. This manifests itself as a rise in the temperature of the water. The heated water is made to flow back into the storage tank before it can re-emit the heat into the surroundings. Due to the large specific heat capacity of water, a significant amount of thermal energy is stored inside the heated water. The continuous flow of warm water out from the panel means heat is being continuously removed from our shading panel, thereby achieving effective cooling. At the same time, the removed thermal energy is not wasted, but retained in the warm water for other uses, such as bathing.
We carried out a series of experiments using our homemade device over a period of 2 weeks. The result shows that our solar curtain is able to raise the temperature of 40 liters of tap water from 30.5 degrees Celsius to 40.5 degrees Celsius when switched on for 2 hours on an average sunny afternoon. If a better location is available, better results could have been obtained.
We also measure the temperature in the region just above and below our device. As you can see, the temperature below the device is significantly lower. This shows that the effective cooling has been achieved. Although we are able to obtain some positive results using our homemade device, it is still far from perfection. Some of the possible areas for improvement could be 1. To use dull black Teflon for more efficient absorption of solar radiation. 2. To improve the design of the storage tank, such as adding a floating lid. The floating lid can be a circular styrofoam board with a diameter which is slightly smaller than the tank. It should effectively reduce heat loss within the tank via convection even if the tank is not full.